thing. And let's work on the final two sections of the lecture, which is one, which are one non-PY, another one system PY. And today let's focus on the non-PY. Um, so basically, non-PY is a library, and you should know that it provides many fast operations on arrays, which is very important in many statistic or data analysis applications. Oh, first of all, I would like I would like to ask you one question. Have you learned linear algebra and some calculus? Have you taken that courses?
Not linear algebra.
Oh, not linear algebra. Oh, okay. Well, um, in that sense, I might need to adjust those content I will teach you because basically non-PY involves a lot of linear algebra. I might need to give you some more introduction in linear algebra in next week's lecture, such that you will have sufficient background to understand I will teach in the lectures about these libraries. Basically, linear algebra is all about how you solve those equations, deal with arrays and matrix. So basically, the non-PY is created in order to serve that purpose. That is providing fast operations on multidimensional arrays and matrices. If you ever use MATLAB or even R language, you will immediately realize, well, non-PY is quite similar to MATLAB or R programming, R language. Of course, there's some difference between them, but you will see a lot of similarity as well in terms of the way they represent those data structures like array, matrix, calculate those, do the relevant calculations around matrix and arrays, like computing the trace, the rank, the determinant of a matrix, and so on and so forth. So basically, this non-PY actually is very optimized solution compared to those general methods Python provide. So it's recommended to utilize this library when you when you are dealing with those calculations, especially when the dimension of the array or the matrix are large. The efficiency is critical. So you have to make sure you are using the most efficient way to solve these questions. And let's look at some of the fundamentals. If you ever have if you have anything you don't understand or you haven't learned the concept, just let me know. And then I will prepare the background in next week's class or in the lab session even. Just remind me when you have any difficulty to understand my lectures. All right. So basically, to start up a program utilizing non-PY library, so the first thing first is to import this library, like the one shown here. So basically, these codes does the import function. This numpy is the library name, and this is the name you have yourself. You can rename it to anything you want, but and once you determine which name you put here, you will always use it in your following code, like the one showing here. Basically, this MP could be considered as an object. And you with this object, you can access all the methods, meaning the functions under this library, numpy library. Basically, this line of code is equivalent to you create a MP object, which is the an instant of numpy, and you are using all the functions and also the attributes. I mean the methods and attributes of that class or object. So first thing first is to create an array utilizing this library. So as you can see here, the way you create array is to use this array function. You can either create the array using list or tuples. So as you can see, if you ever see a squared bracket, that means, okay, it represents a list. And basically, this array method or function takes a list, takes this list, and create an array like this. So that's the way you think of this this line of code. So basically, array is like a queue, and you just store the data to the queue, and it's more efficient than list because it utilizes a static amount of memories in the computer's main memory, meaning you just reserve a certain amount of memory to store the data, and you always access the data using that chunk of memory, and do any other operations with it. So that is a much more efficient way when you know exactly what the data are, and that's how you understand an array. So basically, that's the way you create the array. If you ever use if you use type, you can have this result. It shows, okay, that's from the numpy library, and the type of the array is an ND means n-dimensional array. So basically, this two letter here means n-dimensional and array, right? All right. Also, as I mentioned, you can use tuples to create the array as well. Basically, if you look at here, right, when you see this parenthesis, that indicates, okay, you have a tuple over here, and these are the elements in this tuple. And basically, this function array takes tuple as well and create an array like this. Basically, either way is fine. It will take either list or tuple to create this array. All right. Any questions so far? Quite simple, right? Also, that could be two-dimensional array, which we can also call it a matrix. So have you ever heard about matrix? Anyone who hear about matrix?
I've heard of matrix C, like matrices and stuff.
Oh, okay.
That was a while ago.
Oh, okay. Okay, let me give you a little intro. I will give you more background material or intros to learn about. But a matrix is like a grade. You can think of it's a grade, 2D grade. So basically, the grid has rows, right? This is a row 1. If you look at the whole thing, it's a row 1, and this is a row. Maybe I just it's not good. And this is a row 2, right? This is this basically from here to here, this is a row, and from here to here, this is another row, right? And you also have column. So from the bottom to top, that's one column, and this is another one. I can put it here, C1 and C2. So there are 2 column and 2 rows. If you have a function and has input like this, basically it creates a 2 by 2 matrix or 2 row by 2 column matrix. And this 0, 1, which we call it the row vector. This is a row vector. I put it R1, and this is another row vector R2. So that indicates, okay, you have 2 rows, and in the first row, you have 2 elements, 0, 1. And you have second row, and the second row has also 2 elements, 2, 3. Oh, all right. It's hard to write. Okay, anyway, maybe I can put. All right, that is a so-called a matrix, and this is a 2D matrix. And have you ever played the Rubik cube? Have you ever played that? The Rubik cube.
Yeah.
Yes.
It's a 3D matrix. If you take each of those small cuboid or the cube as one element, it gives you a row, a column, and also another dimension. Basically, let me try to draw it. Okay, so you have this, and this, right? If you use this I, J, K, and let me try to draw a Rubik cube. Oh, it's really hard to draw. But I will try my best. Okay, anyway. But anyway, you got the idea. So each of the small cube is one element. And similarly, you have the rows, which is in this direction, and a column, which is in this direction, and also the levels in this direction. So usually we have rarely chance to work with 3-dimensional matrix. Usually the most widely or in most of the cases we deal with will be the 2D matrix. And basically, the array can be perfectly utilized to represent this kind of 2D matrix. And if basically this is one column, I mean one row, and this is another row, right? Turns out you will have an array created with the 2 row vectors. All right, any questions so far? I know if you haven't learned about matrix, you might have little confusion here, but just let me know. I will try my best to explain it. Okay, good. So as you can see here, in this 2D matrix, what you have are all integers. But that could be some other data type to form a 2D array or matrix. In this case, you have a 1D array. That is only a vector. You have 3, which is the integer, and also a string, 4.5. So you could have an array with different type of data stored in the same array. But if you want to create a multi-dimensional, 2-dimensional array in this way, you will have trouble. So what you have is basically this represents the elements. You have an element 3 and also another string element, which is a text 4.5. And then you have this another list, 1 and -2. If you write this line in your Jupyter Notebook, there will be an error. So Jupyter Notebook or Python does not allow you, or NumPy does not allow you to define an array like this. So you can either just define a 1-dimensional array like this. Basically, you will have each of the elements 3, 4.5, text 1, and -2. And if you write in this way, basically the NumPy will generate a 1D array. Means you only have one line, and you just flat out all the data and put it in one line. And it turns out you have 4 elements, and it converts all the elements to strings, to text. Oh, shoot. Which are 3, 4.5, 1, and -2. So that's one way you could deal with the data like this. Or you could generate a 2-dimensional array by putting things like this. And again, this is the first row, and this is the second row. And because you have multiple different data type, the NumPy just convert them, all the data, to the string type. Turns out you have this array, and here shows you the type, which is the Unicode text. So that's how you create the array. Basically, you learn how the 2D array to be created, not only the 1D array. 1D is just simple. Basically, it just lists out all the elements and put them one after another. You can keep on going, right? But 2D, you have rows, first row, second row, and each of the row vector will be there, and you just create this 2D array by put one row upon another, and that's it. So any questions so far? Good, right? So also there are some simple ways to create a range of data. If you want to create some data which you could use the arange function. If you the number you put here, that means how many elements you have, And because if you just put a 6 here, it will consider you will create an array with 6 elements, and it starts from 0. And if the first element is 0, it turns out what you have is 0, 1, 2, 3, 4, 5, which are 6 elements. If you put more parameter for this arange function, there will be more variations. For example, if you put 3 parameter like this, the first one is the starting element, and the last one is this and this end element. It turns out will give you, and the third one is give you the intervals. That means you just accumulate this to the, I mean, you just accumulate the data by this amount. For example, if you look at here, this -2 is the starting, right? And then you add on to this -2 to add on this number to, with this 0.5, then you have this one, and go again, that's this one, -1, and again, and again, and again, right? Now you will have now you will have all these number created. So basically this gives you not only the range, but also the step, how much you want to increase. So any question? Okay, so there's another function which is called this line space. So basically, that will create an array by taking these 3 parameters. So again, this is the starting point, and this is the end point. And this 5 means there will be 5 elements equally distributed between 0 and 2. And this function will automatically generate will generate the interior ones and make sure they have the equal difference between the neighboring 2 numbers. So as you can see here, this is start and this is end, and the total number of elements are 5. So you can compute, okay, the step size will be 0.5. That means when you have the next number, basically you want to add 0.5 to the previous one. Turns out you will have all the numbers which are equally distributed between 0 and 2, right? Sometimes you just want to create those I would say the matrix consisting of all number ones. What you have will be basically utilize this ones function. Again, you always need to use this NP, which is again an instance of a non-PY class, and it takes these 2 parameters in a list. Of course, you can take more if you are creating matrices with even higher dimension than 2. If you put a like 2, 3, 2, that means you want a matrix in this direction. You have 2 rows and 3 columns, and also another 2 levels in the other dimension. It's basically it's a 3D matrix again. but we don't want to get confused in talking about a 3D matrix. Let's focus on the 2D. So this 2 will be, okay, the number of rows, 2 row, and 3 columns. And this, once you write the code like this, it will create a matrix in which each of the elements is 1. And also it's a 2 by 3 matrix, means 2 row and 3 column, right? That's how it looks like. Because you are literally creating matrix which are all ones in the matrix. Or you could create a matrix with all zeros. That's possible in many cases. Basically, if just looking at the name, you will understand, okay, this matrix will be all zeros inside. And again, the dimensions 2, 3, 2 rows, 3 columns, all zeros. All right. Any question? So what about if you just put 1 parameter here? So it will create a 1-dimensional matrix or a 1-dimensional array. And it turns out it will be something like this, just 1 rows, right? You just, again, just think of it's like a cube. And each of the element will be 1 by 1. And you can decide, okay, you want 3 elements in this array, 1D array, or 1D matrix. All right. And I think if you haven't learned about linear algebra, then you probably don't know what is a identity matrix or unit matrix. In this case, called unit array. So in matrix, in a 2D matrix, if you have let me erase this. So in the matrix, if you have something like this, so basically you have only the diagonal has non-zero elements, and they are 1. All other places there are zeros. So this is called the identity matrix or the unit matrix, or here unit arrays. So this is the 2D one, 2D case. For the 3D one is similar. Just look at the diagonal. Right? Just look at whether, okay, you have this diagonal has all 1s and all other places has all zeros. If that's the case, that's the unit arrays. So this will give you the idea how you could create a so-called unit matrix. So if you use this I matrix and just put a number 2, that means you are creating a 2D identity matrix or unit matrix. Otherwise, you could put 3 or any other number, and it will automatically create those 3 by 3 or 4 by 4 or even more more rows and columns, right? That's the identity matrix. So as I mentioned, so this kind of identity matrix has only diagonal with non-zero elements, and all other places are zeros. That's actually just a special case of so-called diagonal matrix. Means for the diagonal matrix, that means you have something, you only have non-zero elements for the diagonals. For our other places, they are zeros. But the only thing is it may not be ones. Only diagonal matrices with elements, all elements on the diagonal to be one, you can call it unit matrix. Otherwise, it's just a diagonal matrix. So there's a function like this. So basically, you first create a 2D array. I mean, a 1D array with 3 elements, 1, 2, 3, and then this diag function takes this array and create a 2D diagonal array for you. And it will take whatever you put here to the diagonal. And that's the matrix look like. Any question here? Okay. So there are also attributes of the array you could look at. First of all, you have this ending attributes, which will give you the dimension of this matrix. For example, like this, that's the dimension. If you have a like, for example, what we had previously, that's a 3x3 matrix, right? It will return to the value 2. This 3x3 matrix is still a 2-dimensional matrix. This 3x3 means 3 rows by 3 columns, but still it has rows and only rows and columns, right? It has no such a it has it does not have the other dimension, which could be the levels, right? As I mentioned, there could be 3-dimensional matrix like the Rubik cube, but this still a 2-dimensional one. It's you can still think of it's on a plane, and it has rows and the columns, right? Also the shape, right? This shape function will gives you the length of each dimension. Means how many rows you have, 3, and how many columns you have, another 3, right? 3x3 matrix. And the size give you how many numbers of the elements in this 3x3 matrix. Because it's a 3x3, right? That means you have 3 rows, 3 columns, and turns out 3 times 3 is 9 elements inside this matrix. So that's some attributes of the array or matrix you have. You could always reshape the array or matrix you created. For example, originally you create a 1-dimensional array like this, and you use the arange function. It generates 6 numbers, right? And something like this. And for some reason, for some application, you want to convert this 1-dimensional array to a 2-row, 3-column matrix. So that means you want this part to be 1 row and this part to be another row. What you gonna do? It's very simple. Basically, this reshape function will do what you want. Basically, once you call this reshape function and it has specify the row and the column numbers here, it will automatically convert this original C matrix, right, to a 2x3 matrix like this, 2 row by 3 column, right? So again, you have again, if you look at the original matrix, you will and you print it out. What you will see is, well, it's still one-dimensional, but you are already called the reshape function, right? But why when you check the C array, it's still a one-dimensional one? That is because this reshaping is not done in place. Means when you call this reshape function, actually it take the original data in the C matrix and convert it to a 2 by 3 matrix and return this matrix. On the other hand, it does not change the original C. So that means if you write the line like this, means it will take check the elements in C and reshape it to a 2 by 3 matrix and return it and assign this returned matrix to the original C. Then you will see, well, the C has been changed. So you have to have another variable or the original C to store this returned result, which
Professor?
Yeah.
What happens if you don't, if you have an odd amount of digits in the array? Like say you had 7 digits and you tried to make it a 2 by 3, would it just give you an error?
You mean
say it went from 0 to 6 instead of 0 to 5?
Yeah, that could be an error. So
Okay.
it won't create a 2 by 3. That will, because it's there's no way to house the 7 elements in a 2 by 3.
What if you don't know how many elements are in the array? Like say you have a data file and you want to make an array and then organize it into matrices. Is there a way to have it like continuously add to a specific number?
The answer is before you could create the array, you definitely want to keep them in the list. Once you keep it in the list, you will know how many elements you have in the list, and then you can decide how many what kind of a matrix you want to create.
So then you could use an if statement to make sure.
Yeah.
Okay.
Yep.
Or try. You could do a try.
Yeah, basically you could use some you could set up some conditions to see what kind of matrix you want to create. You have to you have to be very clear what kind of matrix you will deal with. Yeah, that could be some cases you are not able to create a like 2 by 3 because there's some empty data missing. Then in that case you want to just fill and 0 there or put something there, and such that it will successfully let you to create the matrix.
Okay, and then when you actually tell it to reshape an array into a matrix, it just does it in order from digit number 0 to digit number however many there are, and like it'll just keep filling out in order.
Yeah.
Like the array is 0 to 5, so you have it as make a 2 by 3 matrix. It puts 0 to 2 always in the first slot and 3, 4, 5 always in the second slot.
Yeah.
Okay.
Yeah.
Thank you.
Yeah, definitely you have the chance to practice in the lab sessions for those functions, and this is the way how you rearrange the data. So if you have some other if, for example, if you just want to put one determined specified parameter like 3 here, means you just want to have 3 rows, and you can just put a -1 here. That means it's an unspecified. By doing so, it will automatically generate a 3-row matrix, and according to what the data you have, it will automatically divide it to different number of columns. In this case, you have 6 elements. That means you can create a 3x2 matrix in this way. There's also a method to flat out a 2D matrix to a 3D one. Let's see, C is already a 3x2 or matrix. I mean 2x3 matrix. Sorry, and it turns out if you call this function, it will return a flattened matrix, which is a 1D matrix, by reading each of the rows and then the second row and the third row. Basically, if you have these 3 rows, I would say R1, R2, R3. Let's say you have something like this. So this function will, it turns out, will put R1, R2, and R3. And one by I mean, put these 3 rows one after another to form a long one-dimensional array. So that's this function does, and it helps you to flatten out a 2D dimensional matrix to a 1D. And also, this flattening function is not a in-place operation, meaning this will, if you just call the function like this, it will not change the C. Actually, it takes the data in C and return a new one-dimensional array. So you have to use another variable or assign this returned one-dimensional array to the original C, such that you could have the result. Yep. So another very useful or convenient operation for those these array in the non-PY is this element-wise operations. For example, you define an matrix like this, an array like this, right? And one thing you could do is you could generate another array, which is also a 4 elements array, starting from 2 and ends from 6. So now you have these 2 array, which is A and B, right? If you write something like this, it turns out what it does is it will add each of the elements in the 2 arrays according to their orders. So what it does is 20 plus 2, 30 plus 3, 40 plus 4, and 50 plus 15. And then return a new array and assign it to this new variable C. It turns out you will see actually C is the result for these element-wise addition. You can also do the element-wise subtraction. For example, like this. Basically, what it does is 20 minus 2, 30 minus 3, 40 minus 4, and 50 minus 5. And then the result will be returned and assigned to variable C. It's 18, 27, 36, and 45. Also, the multiplication. If you have a line of code like this, so A times B, what it does is, well, each of the element will be multiplied together. 20 multiplied by 2, which is 40, 30 multiplied by 3, 90, and 40 multiplied by 4, which is 160, and 50 multiplied by 5, which is 250, right? And here shows you the result. That is very different from these kind of operations for list. I will show you some of the difference in the later slides. But as you can see, you could do this element-wise operation easily by just using these kind of operators. Also, there could be some division happens. Again, let me write A like this. That's 20, 30, 40, and 50, right? And B is 2, 3, 4, 5, right? So again, that's the element-wise operation. So 20 divided by 2, which is 10, 30 divided by 3, 10, another 10 is a result from 40 divided by 4, and 50 divided by 5, another 10. So you have all the result for these per element operations. And this is the power element, power operator, right? Again, it will be applied per element. 2 powered by 2, which is 4, 3 powered by 2, 9, 4 powered by 2, 16, and 5 powered by 2, which is 25, right? Also, sine function. Again, take each of the elements of the array A and compute the sign for each of the element and return the result. Also, similarly, you have the exponential function, and here's the result, and the square root of each of the elements, 20, 30, 40, and 50. Right? And here, it is a expression. Basically, it will compare each of the elements with 35. So if we look at the first element, 20, whether 20 is greater, is smaller or equal 35, the answer is yes, right? It's actually smaller than 35. So it is true. How about 30? Yes, right? It's smaller than 35. Another true. 40. In this case, 40 is greater than 35, so it's a false. 50 is also greater than 35, so another false. So again, if you are using these operators for the array, what it does is it will do these kind of per element operation and return the result. Right? That will actually that's very convenient in many of the applications. Just imagine, let's say you have a series of you have an array. Let's say you have an array A. Let's take A and B for example, and all these. Let's see A stars, and you have. Let's see, you have 4 class. Let's see our ICE 200. Now we have 4 class. I don't know why, but that's the case. And 4 classes. And if you use A to store the summation of the midterm 1's score, which is 20, 30, 40, and 50 for the 4 classes. And use B to store the number of students for the 4 classes. In this case, class 1 has 2 students, class 2 has 3, class 3 have 4, and class 4 have 5. Now, the question is to compute the average score for each of the class in the, let's see, midterm exam. So what you could do is just use one line of code. It turns out the C will give you this 10, 10, 10, 10. What it does is 20 divided by 2, 30 divided by 3, and 40 divided by 4, 50 divided by 5. And it computes the average because this is the summation and this is the number of people, and turns out this is the average, right? Just one line of code, it does everything for you. So that could be one possible use case for this kind of operation. It's very convenient. You don't need to do any loop or whatever, and just to use this. Otherwise, you have, if you think about if you are using a list, probably you will do a for loop and take the score out in each of the iteration, and take the summation out and take the number of student out in each of the iteration, and do the division, and then store them in somewhere, and so on and so forth. But for this kind of element-wise operation, simple, just one line of code. All right, any question? Okay, let's look at more operations. So now you have, let's say you have an A matrix with 2 rows, 1, 1, and 0, 1. Basically, once you create the matrix like this, and it is something showing here, and another B matrix with 2 row as well, 2, 0, and 3, 4. That's what it looked like now. If you have a multiplication of the 2 matrix A and B, so what it does is if you use this multiplication operator, what it does is it will do the element-wise production or multiplication. That is, let's look at 2 multiplied by 1, so that's 2, and 0 multiplied by 1, that's 0. 0 multiplied by 3, that's 0. 1 multiplied by 4, that's 4. So exactly this result. But on the other hand, if you use this dot function and apply this function to A and B, actually what it does is matrix production. I think because of you haven't learned linear algebra, you probably don't know what this does. I think it's hard to understand, but one thing I could tell you is it is totally different from this element-wise production. So basically, it gives you only. I mean, they are totally different. And if you call this dot function, so it will do this matrix production. Otherwise, if you call this multiplication, this star sign, star operator, what it does is element product. So just keep this in mind. All right. So as I mentioned, these kind of operator are different from the ones for list. So first of all, there's no element-wise operations for list. Also, there's no subtraction and division operation defined for lists. Let's look at this one. So this A is a list, right? And that's the 4 element in this list. And you can also create another list like this with 2, 3, 4, 5, which is exactly the same as the previous example. So what you do is if you add the 2 together. So turns out it does not do any element-wise operation. What it does is you actually append element the list B in the end of list A. So the result will be a larger list consists of both elements from A and B in the order of first the element A and then the element B, right? That is what it does. Also, if you look at this multiplication operator, if you write A times 2, what it does is it will repeat the element of A again and generate a new list consisting of the duplicated elements as well of in the A list. So basically, that is what it looks like. This is the original A, and this is the duplicate element shown here. So you can see it's totally different, right? For the these kind of operation with lists and the ones with array powered by NumPy. So you have to keep in mind and make sure you are using the right right thing, right? If you want to do this element-wise operation, do not use the list directly. Otherwise, it will give you something like this. Any question? Okay. So as I mentioned, it's very convenient to utilize the NumPy in many statistic questions. For example, let's look at this this case. You have a matrix A, which is a 2-row and a 2-columns matrix, right? And you could simply call one function sum. And what it does is it will sum up every element in this matrix. Basically, it computes the summation of 0, 1, 2, 3. It turns out it's 6. Or you could specify you want to have the column summed up or row summed up by specifying this parameter axis. If you put 0, that means you are adding up each of the column. Means basically you add this column to 0 plus 2, which is 2, right? And then add up these two together in the same column, and that's the 4. Or you put 1 here, so it will add up the element in the same row. In this case, 0 plus, let me use another color. Okay. Maybe green is better. So in this case, 0 and 1, they are the same row. So that's 1, and 2 and 2 plus 5, 2 and 3 are the same row. It turns out you have this 5 by specifying the different numbers for this axis parameter. Right? It's very simple. Just imagine, I mean, just for a 2x2 matrix is a very, I mean, trivial, right? But think about you have hundreds or even just a few like 50, and you want to do some such kind of statistic. It's really troublesome or tedious to write it using a loop or something. But using this library, NumPy library, you can simply call the function like this, and it does the work for you. Again, it will not change this. It will not change the original A. Instead, it returns a new array, and you need to use another variable to store it, right? There are also some other operator like find the minimums, maximum in the matrix. Again, the matrix is look like 0, 1, 2, 3, right? And then, yeah. So what is the minimum number in this matrix? 0, right? This one. What is the maximum? 3, right? So what is the mean? Basically, that's basically the summation is 6, and there are 4 elements. 6 over 4, which is 1.5, right? 6 over 4. What is the median of A? And you can do the computation as well. It's also 1.5. And what is the variation? I think have you learned about this statistics, standard deviation and variance? Have you heard about these concepts?
Yes.
Yes. Okay.
Yeah, we're learning about that. Yeah.
Okay. Good. Then you probably understand what are they, but basically it does these statistics for you by simply call the function. This is the standard deviation. And this is the variance. This is the median. Okay, it gives you the full name, full spelling. And the mean and the maximum, minimum. So it has all these functions built in, and which will ease your effort to write the code. And another other some operators related to linear algebra. I will try my best to explain. If you have any questions you don't understand, just let me know, because I mean, many of you haven't learned about linear algebra, but let's look at it. Again, this matrix is 0, 1, and 2, 3. So there's a function called transpose. So what transpose does is basically it will convert the row to be the column to be the row. In this case, this 0, 1 is the first column, first row, right? So this transpose will convert the first column, first row to be the first column, which is this 0, 1. And the second row, 2, 3, to be the second column. So it will change change the original matrix to something like this. And that is the exact same result this function will return. So another function is the inverse. I think it's hard to explain an inverse. So basically, you can just consider something like this. So the inverse is usually represented by something like this. This is the inverse of matrix A, and an inverse matrix times its original matrix will be this identity matrix. That is, in this case, that is all the non-zero elements are on the diagonal, and these elements are all 1 on the diagonal. So that's the inverse matrix of A. If any basically the inverse matrix is if the multiplication of the inverse and the original one is the identity matrix. So that matrix is called the inverse. I think it's really hard to explain without any linear algebra background. I think we probably can skip this a little bit because it's not that critical, and I could explain you better with some background linear algebra knowledge. Let's skip it for now. Of course, there are some other operations for linear algebras. Okay, I think here we might have a better understanding because it has nothing to do with the linear algebra. Oh, all right. So what you also want to know is the random number generation functions for this non-PY functions. So what it does is, for example, like this one. There are a few parameters. So let's look at the last one first. So basically, the last one gives you the idea what will be the shape of this array look like. So that is size equals parentheses 4, comma 4 parentheses. So this indicates you want to have a 4x4 matrix. So there will be 4 rows and 4 columns. 4 rows, 1, 2, 3, 4, and 1, 2, 3, 4. My drawing is so bad, but you understand. There are 4 rows and 4 columns. And also, there will be a random number filled in these cells, these positions. And this controls how that random number look like. So basically what it does is, if you ever, basically this 85 will be a reference number. And this 10 shows you, give you the idea how, basically, how I explain it. So let's see if this is the number axis, and this is 85, and basically that's the first input, and then you have 10. That means, well, you want to generate a random number from 95 to from 75 to 95. So basically that's the width of this band region. So that means, well, you will have some numbers generate in this region, and it should follows the normal distribution. Means it will have more chance to generate the number close to 85 and have lower chance to this 75 and 95. That's how these variables make sense. And any question? Do you understand it? Okay, good. So I think that's a little confusing, but that's how it looks like. You have that's the mean value, and you have a range, and you want some random number generated in that range, and fill in a matrix which is in the shape 4x4, and that's it. That's what this code does. All right. Similarly, you could have another 4x4 matrix by simply using the random function and generate a series of random number here. All right. When you can always use other functions together with this random number generator, and it turns out you can, for example, you generate a random matrix samples, and then you can directly compute the mean of this matrix by calling this dot mean function. And you can see it's a 100 by 100 matrix, right? Turns out you will have this mean value over here, which is very convenient. So another very important function is the sorting function. So for the sorting, you can always sort the function in different ways. I think we ran out of the time, and there are still 2-3 slides remains, and I will keep on talking about in the next lectures, and together with the system PY. I think in this section there are some concept you might not be familiar with. Please, if you have any questions, just stop me and ask, and I can explain it for you. All right. Otherwise, you could meet some problems when you complete the final exam questions. All right. Okay. Thanks for your attention.
Thank you.
Yep.
Thank you, Professor. See you on Thursday.
Yep. See you.